Hey guys, it's Henry, and we're going to be doing a problem on glancing collisions. Alright, two cars are approaching. What's happening? Um, Two cars are approaching each other in a T intersection. Car 1, which is 1100 kilograms. Let's car 1, which is 1100 kilograms, and it's going to go 23 meters per second. The other car, I'm traveling from south to north, is 1305, traveling 100 seconds. And they're going to crash. It's perfectly inelastic. That means the VF1 equals VF2. And find the velocity and angle of both cars. So what do we need to know? Well, first off, PI equals PF. Obviously, momentum is going to be conserved. But this problem is a little different. We're going to go on two axes. So we're going to have the x-axis and the y-axis. So let's plot the momentum on the x-axis. So we're going to have m1 v1 on the x plus m2 v2 on the x. And for the y, we're going to have m1 v1 for the y plus m2 y. And this is going to be obviously by cosine of the angle, and it's by the sine of the angle because we're going on y and x. So over here we can see that car 2, that's car 2 has no horizontal acceleration, therefore we turn this to 0. Our momentum on the x-axis is going to be nice easy m1 is higher than that. So looks good enough. And this should be a y. It's kind of pretty much the same thing's going to happen over here. We're going to see that our first car has no velocity on the y, therefore it turns into 0, and y is going to equal to y. So I should have probably gotten my calculator, but I don't have it. It's going to be a little tough, but it's alright. So let's think of this. The car is going to shoot out in an angle theta, and we know that the momentum on both axes is going to be preserved, right? So pxi equals pxf and pyi equal pyf. Therefore, we can say that py is going to equal the same thing on the both before and after. So in order to find this angle, well, we can just go with the tangent. I wrote this the wrong way. We can find the tangent of the angle right there. So the tangent is going to be the opposite over the adjacent. Therefore, tangent of the angle is going to be py over x, f, and f. And we know from our equations that pxi is going to equal pxf and pyi is going to equal pyf. And we know what pxi and pyi are. And they're going to equal the same thing. So we can just say that tangent theta is going to equal 2v2y over m1 v1 x. And we can elaborate on this. 1300 times, it's going to be 5 meters per second. And 23 meters. So this is gonna end up being 32.5 divided by 1100 times 20.5. So we're going to get this is going to be divided by 25300, 1.28, 4546. And we can take the inverse and find what that is. So we're gonna go full screen really quickly. I'm pretty sure there's a tangent. Yes, there is. Oh, I had it right there. Hold on. Inverse tangent is going to be, oh my goodness. Whoa, hold on a second. That does not look nice at all. Really? Okay, I'm gonna pause this. I'm gonna go to my calculator. But on my calculator. So see, my calculator says it's 52.1, so that seems much more reasonable. Sorry, Julius, but you're gonna have to edit that one out. And now we know the angle that they shot at, so that's good. And we're gonna go Py P2.1. So now all we need to do is find the velocities. Well, we know that Pi equals Pf, and the sum of all the momentum is going to equal, well, m1v1 plus m2v2, so on and so forth. So for the initial momentum, we're going to get m1, it's going to be that one, m1v1x plus m2v2y, and that's going to equal the final one, which is going to be a little more complicated. Go back into a little bit more complicated. We're going to get different things going on. It's going to be N1 VFX. VF for both of them. Not that. VF for both of them is going to be the same. So we can just say VF M1 VF plus M2 VF. Wait, I'm gonna think this real quick. Oh gosh. I'll come right back.